Hello. For our medical device, we decided to make a rehabilitation device called the Uno Flex. So right now we have the lid off, just for you to see the circuits better, but this would be the top of the device, like that. Okay, so this project makes do of the accelerometer, the LED, a Bluetooth module, and an LCD. Right there, there, and there. As you can see, for the user to be able to tell the angle that they're measuring or rotating a limb or an arm or whatever at a certain degree. The idea of this is that after a large procedure or surgery, people have to practice rotating or stretching like their arms or legs or hips or whatever they got surgery on to be able to regain physical mobility or rotation that they may have lost during the procedure. So as you can see right now, the tilt monitor is reading a degrees of around roughly 0. We had to give it a little buffer room because of the sensitivity of the accelerometer due to gravity. But in a portable manner, we can attach this device onto a limb using these Velcro straps. So I'm just gonna attach this. Okay, like that. Okay, so now you can see that the angle is completely straight and we still have roughly 0 degrees. And I'm going to rotate this upwards. As I rotate it, the angle is going to increase. And once I hit the threshold level, which right now is set to 90 degrees, the blue LED will light up to tell you that you have done that. And then as you move back down, the angle will return to its 0 set, which is around 0 degrees. Can you end it? Okay, so that was in the Z-axis because I moved it towards me. The device also works in other directions, such as if you wanted to move your Arduino, if you wanted to rotate your arm this way, in the Y-axis. So as you can see, the angle will increase, increase, until we hit 90. And then the blue LED will light up, signaling that we hit the threshold level, which again, you can change if you wanted to rotate it less. Okay, so then we want to remove the device. You can just take it out. In addition, using the Bluetooth module, we were able to send the information that's being displayed on the LCD screen to an app that we have over here. So we're going to connect the device, and then this is called an HC05. And then as you can see, the angles are being measured, and you can read them clearly. So this will also assist in the user when they're not holding the device. They can look at it on their phone. In addition, we added a component that if the Arduino detects that a certain angle is being constant, such as in this case between -10 to 10 degrees, for a certain amount of time, the message "time to exercise" will display to remind the user that it's time to rotate or stretch or whatever, and that message will similarly be displayed on the app.
If you look carefully, you notice that our LCD lacks a potentiometer. This is because, as we learned in class, the potentiometer acts as a voltage divider. This allows the user to select exactly what voltage they want to get the correct contrast, which will display the characters. However, we figured out exactly what voltage we needed to get the correct contrast that we wanted. So instead of using a voltage divider, we simply used a wire to connect the LCD from pin 3 to ground.
Okay, now for a look at our code. So we included the Liquid Crystal library for the LCD screen to import all the commands that go with the LCD. Similarly for the Bluetooth module, since it also works based on a serial monitor, we included the software serial library. Then we initialized our pins, RX pin, TX pin for the Bluetooth module, our LED for our LED, and then similarly our sensitivity values and our starting initializers for the for the accelerometer. And then we have all our variables. Then in our setup, we begin the LCD, set the LED as an output pin and set it to low. And then we begin the serial monitor and similarly the Bluetooth monitor. Then in our loop, we have an initial calibration setup. So within the first 2 seconds that the Arduino is turned on or reset, we're going to have it read the values that it gets and then take the average of them, as you can see down here. And then using that angle as the base point, we'll set that as a 0 angle, as you'll see below over here. And every angle that goes on after the 2 seconds will be compared to that angle in order to measure the change in angle. So to actually measure the angle, we take in analog inputs, similar to how we used analog pins in the past, and we divide by 1024 and multiply by, instead of 5, the reference point, since the accelerometer works at a lower voltage. And then to convert our angle measured into a change in angle, like along a coordinate plane, we use the atan2 function, and then multiply by 57.299, which is equivalent to 180 over pi, in order to convert it from radians to degrees. And then there's an offset factor of 180, so we have to add that. Then, so each time we have a variable that stores the difference in the angles, and then that's what's going to be displayed on the LCD. And then we have our code for if the angle, which we call display, is between -10 to 10 for a certain amount of time, it'll track that time using a counter, and then if it hits a certain time, which we have set for 10, but obviously we can change to longer periods of time, it'll read the message time to exercise. And then if the angle is over 90 degrees, then we have the LCD set up onto high, and then we're having a blink, so there was a delay of 100 or 1 second. So now we put the lid back on just for you to see the final product. We have a little hole for our LED to show up, and our LCD, and then our Bluetooth module is just gonna stick out, and you can see the red light lighting up, which means that there's a connection. And then we have a hole over here, which is access to the reset button, so when you want to reset the Arduino, you can easily access that.